Okay, first problem. Okay, 413. Let me expand this so you guys can see a little better. Much better. Here we go. So this is very similar to the clinometer problem where you guys have like your eye heights, you got some structure, trying to find the height of it. So 4113 kind of helps you with that kind of problem. So Camilla decided to find the height of the Empire State Building. She walked a mile away from it, which is 5,280 feet from the tower, found that she had to look at 15.5 degrees to see the top. And you have her eye height, which is 5 feet off the ground. That's awesome. Good. But when you do this, you have to make sure all the units line up. So she's clearly going to find the height of the Empire State Building in terms of feet, not miles, because that'd be kind of weird. It'd be like a decimal. But also her height's 5 feet off the ground. So we have to keep sure we have to make sure all the units are lined up correctly. So if she's staying a mile away from the building, we can't use 1 mile as our units. We have to use feet. So we convert to 5,280 feet and set it up. Of course, the height of the building will be your opposite side. So this is the opposite, right? That's opposite. Actually, I take it back. This is opposite right here, which we're calling X. That's opposite. And that's adjacent. So you do opposite or adjacent. You're good. Solve for X. But you're not out of the woods yet. Once you solve for X, you have to add 5 for height. And the true height of the Empire State Building is 1469 feet. So hopefully that makes sense how to set that up, how to work it out. Some of these other problems are a review of old things. And this is good because we have a final exam in literally a month from now, I think, if I'm not mistaken. Our final, when was our final? Our final is going to be on December. I take it back, on the 16th. You're correct. So 33 days away from today. So it's coming up pretty fast. In 33 days. Yeah. Yeah.
Wait, when is our next test?
Next test will be December 4th. And then the retake exam will be the week after that. Okay. Okay. Oh, okay, you gotta go. All right. Let me give you some other stuff here, William. Here's the homework. And you could watch a video. I'll post a video later today. Yeah. Yeah. All right. And make sure you get the solution key, the homework. You got it? Okay, good. All right, guys, let's keep going because we can't waste time. He's sick. He's gotta go home and rest, dude. And not get us sick. All right.
I'm sick too, though.
Good, go, please. All right.
Actually,
You have to get a note. All right. All right. Yes, question. Go ahead.
What?
Less than 14.
That's fine, but you can't have it to be too small either, though. Because if you say it's less than 14, then you could tell me it could be 1 or 2. Yeah, because if we make it too small, then 10's too big, right? So, guys, what Faith brought up is a really interesting point. So, yes, you have to be less than some of the two sides. That's great. So definitely got to be less than 14. But if you just say that, then you're telling me that anything less than 14 is okay, and that's not true. Because what about 10 being too big? Because if you make ML too small, then MS is physically too long, right? So you have to also catch it before it gets too small. So you got to be between 6 and 14. So I hope that makes sense. Good. Thank you for bringing that up. That's good. For 415, again, old stuff, parallel lines. You see the little markings with arrows. So alpha's got to be 85 as well. And then theta is going to be 68. Because if that's 112, that's 112. Therefore, that has to be 68. Hope you're okay with that. For 511 area, we should notice already, those formulas will always be provided. You'll never have to memorize any formulas for area. We'll give them to you guys. But you just got to use it. You have the 2 bases. You have the height. Plug it in. We're good. So it should be pretty straightforward. Yes. Go ahead. Great question. Let me take a look. I don't know. Yeah, give me, let me. Oh, okay. Now I know. Here's what we do. Let me walk up there. I'll point to it. Okay. So here's how you can tell. Girls, please. I didn't focus. Thank you. Okay, 45, right?
Yeah.
If that's 45 and that's 90, how much is left of that angle right there?
45.
If both of those angles are the same, what does it mean about both these sides? They're the same also. And you're already told that's 4. So that has to be 4.
Which means the only thing left.
We have no choice but to make it 4. And if that's 15 from here to here, and that's 4, that's up to 19. How much is left for that guy? 3. And if that's 3 and 4, using Pythagorean theorem, this hypotenuse is 5. And if that's 4 and 4, it's 4 over 2. Now you can find your perimeter. That's how you do it. You're good.
I didn't like use Pythagoras either. I didn't suck.
You can do that too. 100%. That's fine. That works. Yeah. Yeah. They're good. Maggie, yeah. Yeah. Uh-huh.
5/8 would be
Hmm? Yes, correct. Yes. That's actually a great point you made because that's what we're going to talk about later in this unit about ratios of special right triangles. So 30, 60, 90, 45, 45, 90, those are special right triangles. We're going to have that discussion later. But yes, 100%. That totally makes sense. I'd agree with that. Now, notice the perimeter. Okay, I actually do care about this tremendously, especially for those who are going to do the retake in the second week of December when we're back from Thanksgiving break. Remember, we had radical stuff, and like some of you guys put decimal, some of you guys combine radicals incorrectly. So the perimeter here is an exact form: 42 plus 4 root 2. What does exact form mean? No decimals. You need to leave it in radical form. If you want exact form, we want radicals. So we have 4 and 4 for this triangle here, right? When I do Pythagorean theorem or a trigonometric thing, whatever you want to do, you get 4 root 2 for that side. Yeah, you got to leave it like that and add it to all the other sides. And of course, 4 root 2 is add to 42. Leave it alone. It's fine. Okay, then we get back to some trigonometry for 517. You have a bunch of triangles here. Just use the right trig function. In fact, each of the three are used. Sine, cosine, tangent are all used. Why are we using sine for A? Because the side opposite is what we're trying to find. The hypotenuse is what we're given. Over H, I got to use sine. Why am I using tangent for B? Because the opposite angle, sorry, the opposite side is given to us. The adjacent we want to solve for, so you have to use O and A. For C, we have to use A and H because you're given the adjacent, sorry. You're given the hypotenuse, you want to solve for the adjacent side. Whatever that you have to relate, that's a trig function you have to use. So if you have your unknown, you have your known. So for part C again, what I want to solve? I want to solve for the adjacent because that's right next to the angle 60. What am I given? The hypotenuse, right? Which trig function, you see on the board right there, we have that reference now. Which one involves A and H? Cosine. So I have to use cosine to relate those two sides. Once I have that, I'm set, right? All's good. The last one, I think it's the last one. No, there's still, oh my gosh, it's a long homework. 518, more of the same stuff, just have to interpret information correctly. You got 75-degree angle, height's 26. You want to find the length of the ladder, which is slanted. So great, that's our hypotenuse, solve for it, you're good. True, false stuff, it's false, false, true. Of course, all shapes have 360 symmetry because you just rotate, great, that's fine, right? If a triangle has 60-degree angle, it must be equilateral. Well, no, because the other side, I think it's 59, 61. Do that. To find the area of a shape, you must multiply the length of the base by the height. True for parallelogram or a rectangle, but not true for a triangle because you got to divide by 2. So, okay, good. No questions? All right. Yeah.
True.
No, only if one angle is 60.
Two angles.
What if you have 59, 61? What if you have 120? So yeah.
90 and 30.
If
Right. Good. Draw what? Sorry, not necessarily. I mean, well, yeah. I mean, you should know how to draw a triangle, but what is it you're exactly asking? I don't.
Draw.
Exactly. Not exactly. Just
51.
oh no, don't worry about that. I'm just saying from a numerical standpoint, if one angle is 60, the other two are not guaranteed to be 60 each. They could be different angles, right? 522 is simply algebra review. Hope you're good at that. Just make sure you guys don't forget how to FOIL and multiply stuff out. Using a box could be a good idea. If you want to use a box, you could do that. I strongly recommend that for part B. For 522, the acronym we use is FOIL, first, outside, inside, last. So you multiply 2x with 3x, and 1 with 3x, and -2 with 2, and 1 with -2. If you do that correctly, you should get 6x squared plus 3x minus 4x. Is that negative? I can't read that. Yes, I think it's negative. -2. Yeah, all's good there. So cool.
Yeah.
Yeah, awesome. Good. All right. Okay, so homework review is done. All right, so let's dive into the notes. Hopefully you guys still have the thick note packet. I did produce extra notes for just for today if you forgot yours or lost yours, but hopefully you still have it. I know Mr. Davidson left off with 525, so I want to pick that up, go over that page. I want to do page 3 and a little bit of page 4, and then you guys can work on homework after that. Because I want to be at the same place where he is, so that we're not behind. So we'll start off over here. And I'm gonna have someone do a little reading, and then we'll kind of work on problems together. And I want to go back to the clinometer problem to help you guys with that after we finish this. So, okay. Rain, yeah, it's raining all day today. All right, so let's see. Peter, can you read 525?
Yeah.
All right.
We already
did
did
this
that.
one.
I'm just gonna do it again,
Okay.
really fast.
And we also did 26.
Okay, I just want to review it. That's all.
For the triangle at right, find the measures of angle A and angle B.
Mhm.
Once you have found the measure of the first acute angle, either angle A or B, that knowledge about the angles in the triangle can help you find the second acute.
Okay, perfect. Thank you for reading that. So just to recap really fast, 'cause I know you guys did this with Mr. Davidson, but just to, 'cause it's been now, 3 days since you guys done this. Cosine of A has to equal 14 or 15. Or you could say this, sine of B, either one is fine, whichever one you go with. I don't really care which one you go with. And either method will get you the same final result. But do you see why cosine A is 14 or 15? What's cosine relating? Cosine's ka, right?
Adjacent over height.
The adjacent's clearly 14. The hypotenuse is clearly 15 in relation to angle A. If you're only focused on angle A, then yes, your adjacent is 14, your hypotenuse is 15. And when you solve for it, you have to do this. When you isolate angle A, you have to do the inverse trig function, which has this funny symbol with a -1 as a superscript. And of course, you just punch in the calculator. So this is clearly a calculator thing. And since you guys did do this, what did you guys get for that? For angle A?
21.04.
Perfect. Sounds about right to me. Good. Now, if I do the other one for angle B, go ahead. Yeah.
Over hypotenuse.
Correct.
Don't have opposite angle. So you can't.
No, we do have the opposite side. No, it's not about opposite angles, it's about opposite side. Here's angle B. What side's opposite angle B? That's your opposite side. It's never about angles, it's about sides. Never ever. Nope. So for angle B, you do, yeah, right. We can't do sine of angle A because I don't know what BC is. But I could do the sine of angle B because I know what AC is. And AC is 14. So yeah, that's why sine of angle B makes sense. Hold on, Faith. So angle B will be the inverse sine of 14 or 15. Now, if I do that in the calculator, I know it is because I'm going to do 90 minus 21.04, which I think is 78.96. Is that what you guys got? 68, sorry. Yeah, I did my math wrong. Faith, what's your question?
Only triangles aren't right.
No, only right triangles. There is another thing called the law of sines, law of cosines, which you won't do until pre-calculus. That's another thing, but it does involve, yes, you can use trig for non-right triangles, but that's beyond what we do in this class. But when you use that principle I just talked, it's called the law of sines and law of cosines. You will incorporate the right triangle stuff to understand why those forms work the way they do, but we're not going to do that in this class.
You only do it like with right triangles until like pre-cal.
Correct. Yeah, when you get to pre-cal, you start expanding it to other stuff, right? Junior year. So for you guys, yeah.
Are the cosine, the sin sine, and the tan sine, are those only used to find like the angles of the length, or do they have other uses?
For what do you mean? Other? Yeah, there are other uses of trig. Besides, it's also used for modeling certain like waves for behavior. So yes, it's not just triangles.
Okay.
It has other applications, 100%, especially in physics. It has a lot of application in physics. So anyway, yeah. So now, what knowledge about angles could you use to find the second acute angle if you just find the first one? You could use the fact that all angles in a triangle add up to what?
Went in.
Perfect. Thank you, Lucas. All angles in a triangle add to 180. We know this, yes. So just to recap before I move on, so you guys are okay with all that? All that makes sense?
Yeah.
Okay, cool. So hopefully that seems fine. All angles are triangle up to 180. You got cosine A, sine B, you got all that jazz, all that stuff. So yeah. But you do need to do trig at least once to find one of the angles. Like we can't do this without trig. We need to do trig at least once. You can start with cosine A, sine B, I don't really care. And then once you do that, then the rest is fine. Or another thing you could have done too, you could have done Pythagorean theorem to solve for this side, and then done other trig functions like tangent, for example. But why if you have the two sides already given to you? And then here you guys did 526?
Yeah.
Okay. So really quickly, I'll just set it up. You guys tell me if you guys got this. I'm going to say cosine theta equals 12 over 24. And hopefully, do you guys get theta of 60 degrees?
Yeah.
Yeah, okay. Here, tan theta is 8 over 8, which of course is 1. Do you get theta is 45 degrees?
Yeah.
Okay. Correct, yeah. And so the angles have to be the same. Yep. The opposite angles have to be the same. And then here, sine 57 degrees equals 7 over x. That I cannot do in my head. I'm going to guess, well, it's definitely more than 7. I'd say was probably like 10 point something. I was off. 8 point what? 8.35. Cool. Right. Yeah, and to do that, you have to multiply both sides by x and then divide by the sine of 57. Because you have to get rid of the denominator first and then divide by sin 57 to get the final answer. That works too, yeah. Yeah, I mean, because you could say it's over 1, cross multiply, that works too. Yes, 100%. Yep. Okay, so now let's get a new stuff. Oh, Peter, I think you should read again. It's about you.
Okay.
So why don't you read again? All right. Here we go. Go for it.
Peter cannot figure out what he did wrong. He wrote the equation below to find the missing angle of a triangle. However, his calculator gives him an error message each time trying to calculate the angle. Jerry, his teammate, looked at his work and explained, "Of course your calculator gives you an error. Your cosine ratio is impossible. What is Jerry talking about? And how could she tell without seeing the calculator checking on her calculations?"
Okay. Yes. Why is this bad? Yes, Faith, go ahead.
Be the biggest.
Yes. Correct. Sorry, I know you had your hand raised too. Thank you for contributing there too. So yes, so hypotenuse, and I trust you're going to say the same thing. The hypotenuse must always be bigger than the adjacent or the opposite, right? This must always be true. So when you have this, however, 2.736 is less than 8. And that's a problem. That will be a problem. Because it's what you're telling me is this. Here's theta. Remember, theta is an angle that we draw inside. Here's theta. You're telling me that this is 8. And that's 2.736. This is physically impossible. How can the hypotenuse be less than the leg? Because isn't the hypotenuse opposite a bigger angle? Right? That's physically impossible. Oh, thanks. Yeah, you just can't have that. So you have to guarantee that the numerator is less than the denominator. So for cosine and sine, the numerator must be less than the denominator all the time. Because you can't have, through the hypotenuse is opposite 90 degrees. These two are opposite in acute angle. Right, so those are opposite acute angles. So yeah, you need the hypotenuse to be bigger. And you're telling me that's not when you have it the way it's set up, that way Peter has set up. So be careful about that.
We just say hypotenuse must be greater than the.
No, that's not, that won't be a test question. No, no, it's just more so you understand. So that you if you make a mistake when you're like doing a word problem and you accidentally have things mixed up and you get an error, you don't know why you have an error. Now you know why. It's really more for you to avoid mistakes than anything else. It wouldn't be a direct test question. It's just more a pitfall to avoid. So it's not necessarily a test question. If we do make a test question, which, okay, I gotta be honest, I don't know what the test question will be. If we do, I'll tell you. But in all likelihood, that's not really a test question. It's really more just you're aware. It's an awareness thing. Yeah. Yeah, because yeah, clearly the person had mixed up. So yeah, probably should have been the other way around, right? Because that makes sense. We're okay with all that. No questions? No. Okay. All right, let's keep going. All right, let's look at 514. All right, so Lucas, can you read 537, please?
The Bungling Brothers Circus is in town. You are part of the crew that is setting up this enormous tent. The center pole that holds up the tent is 70 feet tall. To keep it upright, a support cable needs to be attached to the top of the pole so that the cable forms a 60-degree angle with the ground. How long is the cable and how far
Great.
from the pole should the cable
Yeah.
be attached to the ground?
Thanks for reading. I appreciate that. Yeah, so here we go. Here's the ground, right? Here's the ground. Here's the pole. Here's the cable.
The pole's 70 feet.
Correct, yeah. There's a cable. So we have a real life problem. You have a triangle. You got three sides. But physically, in the context of this real world situation, the ground's my horizontal leg, the pole's my vertical leg, the cable's my hypotenuse. So hopefully you have that visual now, right? Okay. So some things I do know that this is not to scale, so that's okay. But I know that's 60 degrees because we're told that. We are told it's upright, so we're gonna assume a right angle here. And we're told that the pole is 70. Okay, so these are the things I know. Now, I want to solve for the cable. I want to solve for the distance that the cable's from the pole or from the base of the pole, right? So let me erase that for now. Erase that for now because I need some space here.
Sine.
Yeah, we're gonna do a variety of things. We'll call this X and I'll call this Y. Yes, for part A. Well, actually, hold on a sec. How long is the cable? Yes, we use sine. That's correct. So sine of 60 degrees equals what over what? Well, sine. Well, where's X? X is not my hypotenuse, right?
Oh.
Oh, yeah, no worries, no worries. I know you meant an unknown. That's all good. I know what you meant. But in the context of the problem, we made it Y. So yeah, okay. And then we can multiply both sides by Y.
80.3.
Yeah, sounds about right to me. Yeah, so you have y times sine 60 degrees equals 70. Y will equal 70 divided by and we get Peter again,
80.83.
80.83. Okay. And that's in feet. And you can use Pythagorean theorem to solve for x. But for part B, which I'll do up above, yeah, go ahead. Yeah, no, I won't. Not that much of a stickler. I mean, it's just more to show you it's not exactly 80.83. I should actually do an approximation symbol. You are correct. No, I'm not gonna care about that. I mean, what I do care about units, and I do warn you guys about units. I'll actually warn you guys again, actually on the test, like next to each question, I'll try to be a little more detailed that way, or rounding as well.
Are you gonna do the thing where you like put in bold at the end of the question, make sure? that
Yes.
you-
100%. I will do that. I'll also remind you guys about the mode, to be in degree mode. I will actually walk around. I'll even try to find someone to watch this class for a few minutes, and I'll walk down to the ASC and make sure you're in degree mode because I don't want you guys to mess that up. Oh, you'll be screwed. Yeah, you'll be host. Yeah, the whole test would be disaster. So we gotta watch out for that. I'll even let the ASC know as well because they have math teachers down there. So yeah.
Why like the sin and the tan not proportional? Because like if you get like tan 45,
Hmm?
you kind of assume that like
Hmm?
tan 15 would then be like 0.33. So why?
It's not so. So what tangent's doing, tangents is looking at the ratio of the opposite and adjacent sides. So just because you change the angle, it doesn't mean that the size would the values would change. It's the angle itself is not proportional to the sides. When you have a certain angle, there's a certain side length that goes with it. It just depends on what angle you have. But if I double my angle, it's because it's not a multiplication thing, right? You're not if you're like multiplying and dividing, like sure, but tangent and sine are their own functions. They don't follow. It's like fine if I double something, it's not the inverse of that's not division, right? So I'm not sure if I'm answering the question correctly, but like sine of 30 is a 1/2, but sine of 60 is not 1, right? It's like 0.8 whatever. So yeah, if I double my angle, but the output's not doubled because remember we're not multiplying and dividing. You're doing just it's like a table of values that you're looking up. Because like sine of 60 is like, okay, if I have 60 degrees, how are those the side opposite and the hypotenuse, how are they related? That's all we care about. So you don't want to assume that. Lastly, for part B, we can say cosine, or I can use tangent. I can say tangent of 60 degrees is 70 over x.
You just do Pythag.
Or Pythag 2. So either that or Pythagorean theorem, where you have x squared plus 70 squared equals 80.83 squared. That too. Yeah. Cosine 60 equals x over y, where you already know what y is. Sure, that works too.
Only round two.
Yeah, there's definitely a few options you could do here. Now, if I work this out, so if I do Pythagorean theorem, let's go here. TI 84. And if I do, okay, mode, remember we gotta switch to degrees. And it'll be 70 divided by tan 60. You should get 40.42. If you work it out. So 40.42. Or if you have Pythagorean theorem, same thing, doesn't really matter. Yes, Clint, good. I don't care. I don't care. It's fine.
44.41.
It's we're close enough. It's okay. That's because I went for a little more exact. I think you round a little too soon. It's not a big deal. Okay. We're good? All right, let's move on to, actually, why don't you guys try these next two? And we'll check in a moment. So I think now you guys can actually set these up.
What?
So hold on, so yeah, wanna go?
Answer your question.
Oh, yeah, well, gentlemen, Faith, go ahead. Very nice, that's very kind. All right,
I did Pythagorean, I got like a different answer.
way different?
Yeah.
Yeah, I'll come check your work. All right, so why don't you guys try 1 and 2? Yeah, good. It's a nice jacket you're wearing, by the way.
Thank you.
Yes, I like it.
Good thing it's not-
Don't leave it around, I might take it, so. All right. All right, so why don't you guys try 1 and 2 about the ladder leaning against the wall, the school flagpole. I'll work it out as well. I'll freeze my screen in the meantime. And Faith, I'll check your work. Right, yeah, good.
I did all of that. and then-
Yeah, can we move on?
Yeah, it's fine.
That is 70 squared plus.
Minus 4900. Yeah, you punched it in wrong. Unless it's 3.49,
Oh, I did. It's 1.3. Oh, see, okay,
Human error,
okay,
right? You're human.
yeah.
That's all. But see, you know something seemed off, so just go back and make sure you punch things correctly. That's all.
Okay.
That's it. But you're human. All right. Can we work these out?
Right, you know. So then you put it in the calculator and you can do negative 10, you know?
You okay, Peter?
Yeah.
All right.
Calculator.
Good. Okay, so far, hopefully you guys are getting this so far. Yes, I think.
75.
Sounds about right. Say again, 75 point what? Yeah, I'll go with your answer. I like it. This sounds good to me. Inverse trick? Degree mode. Go to mode. Mode's in the top of the calculator, and the third row, move it over to degree and hit enter. That should work. Is that gonna be? Yeah, make sure you convert tomorrow's height to feet. 60 divided by 12 is 5 and 2/12 as a mixed number. 2/12 is 1/6. 1/6 is 0.167, so it's 5.167. Okay, I think so. I think I'm right. I think I'm right. Okay. And then that's 11.3 degrees. And the flagpole's 15 feet high. So this right here is me 15.
Wait, for one, do we have to like show the steps like in between like tan theta over 90/5 and then straight to like theta? Like we have to show like the in between steps.
Like this right here?
Yeah, like in between the first thing.
Yeah, you should show that, the one I just circled.
No, like in between, because when Mr. Davidson
Wait,
was like
what?
explaining to us, he had like a lot of steps in between them. So do we need
Well,
those
like what?
steps?
Like what in between? That's enough work. I don't know either.
Accept it.
I don't know what it is that either. I'll ask him. I don't know.
Okay.
That seems fine to me. I mean, that's all the work you need to show. He may just was just offer explanations just so to explain, but I don't think in terms of supporting your work, That's support your work, just so you know.
Okay, that's
Okay,
it.
okay, yes, yes. Connor, go ahead.
For 5.167, I wanted to the nearest.
No, don't do that.
5.1.
Don't do that, because that's gonna be a little off. Yeah, try to be as, oh, you said nearest 10th. Oh, 100th is okay, actually. If you 5.17, you're, that's okay. I think you said 5.2, sorry. That could be okay. For X, let's find out.
Oh, that's the wrong place. That's on the
Hands
other
11.3 degrees. So I have to take away the person's height from 15, just so you know. So 15 is the height of the flagpole, guys, but I gotta take away that person's height, which is 9.833, because that's the true length of that side. Whoa. That's probably the internet.
over.
No, the internet went out probably. Hold on.
Oh,
Actually,
no.
yes. Probably gonna go home.
Hold on.
If the school gets power shut down, you don't have to go to school the next day. What happens is the generator
No, the
gets
last
shut
time
down.
the power went out, we had our phones for the rest of the school day and we didn't have to do any work online.
Hold on. I will do this. I will use my HDMI cable. Excuse me? You're good. You're good.
Would the lights go out?
No, it's, I think the internet just went out.
The internet is different than electricity. The electricity. Yeah.
Here we go. It's okay.
Isn't the internet electronic?
No, yeah, okay.
No, that's different though.
All internet is electricity, but not all electricity.
Oh.
Oh, look at that. You just put him in his place, man. Alright. Hold on. What? Why is it not connecting? Hmm. Okay, give me a sec, guys. Let's disconnect from the projector. HDMI. Ah. My. HDMI 1. Come on. Ah, thank God. Okay.
Oh.
The cable's loose. That's all. No, it's just the cable. No, I'm still using HDMI. I'm not connecting by wireless. Anyhow, so you solve for X. If we solve for X, you're gonna wind up doing 9.833. Yes, Faith, go ahead.
You don't actually like need to use like the for height at all.
No, you did. What you do, because the flagpole was 15, but this side here is 15 minus the heights. Right? Yeah, that's what you had to do. I know, it seems to happen a lot.
Why do we that height though, if we're just trying to find X, which is the same length as if she was.
Yeah,
standing?
but the thing is that you're measuring this angle from our eyes, not from the ground. That's the reason why.
Wait, is
And
this,
if you're measuring from the ground, then the angle would have been higher.
Would be different.
Yes.
is this triangle like, so this one wouldn't be correct? This triangle's not correct?
Nope.
It has to be from your.
Yeah, it has to be from our eyes. So let's go back to the calculator again. That's gonna be 9.8. So 15 minus 62 over 12. Yes, divide that by tan 11.3. And you get 49.21.
Wait, for two.
It should be 49.21, yeah.
Wait.
Questions?
Wait, I don't understand why you have to subtract.
Okay, so here's the deal. The flagpole is from here to here, right? That's the flagpole, right? That's 15. This right here is the person's height. But the triangle I drew was only from here to here. This is not 15. That's 15 minus that. That's why I have to go 9.33. That's the reason why. Does that make sense, guys? Why it's 9.33? You guys see that? So we don't want to make it, now this is definitely a test question, I'll tell you for sure. This will be a test question. You have to understand physically what's happening. From the top of the flagpole to the ground, that's course 15 feet, 'cause you're told that. But the person's measuring the angle from her eyes, right? Not from her feet, from her eyes. So you have to start the side over here. So this side, this vertical side of the right triangle, starts from her eye height to the top of the flagpole. So you have to deduct her height from 15 to get that true side, right? That true side is actually 9.833. That's what should be involved in the equation, not 15, just so you know. And then you can do the rest after that. Does that make sense? Right. Clay, you had a question?
Going all the way to the ground, would it still be 11.3?
No. No, because what happens is if you, let's say you lie on the ground. And like you're like I don't know, one of those like, I don't know, soldiers are shooting a like it sounds terrible saying, but I don't know. But like so you lie on the ground and you like look up from the ground, that would be a much steeper angle. The angle would have changed. But I don't know what that angle would have been, because we're not told that value. Because here's the thing, I know what you're telling me. You're telling me this, right?
Yeah.
You want to do that? That is not 11.3. That's even more than 11.3.
Going flat on the line, like I'm not trying to.
Oh, like here?
Yeah,
You can do that, and that would be 11.3.
but then you get like.
But then, the problem is that then this would be a different value. So what you want to know for, since I don't know what that distance is.
Yeah.
Either way, you're still not running into a problem. So. That's a good observation though, I like that. You could. That might be a good test problem, actually. Thank you for the idea. Okay. Okay, last one, let's do 39, then we're done. And then I'm just gonna talk about the clinometer worksheet just a little more, and I have another worksheet to give you guys. Okay, Forrest needs to repaint the right side of his house because sunlight and rain have caused the paint to peel. Each can of paint states it will cover 150 square feet. Okay, girls, let's focus. Thanks. All right, work with the team to find area that will be painted. Assuming that Forrest can only buy whole cans of paint. So let's say he needs like 5.6 cans. You still need to buy 6 cans of paint, right? Little bit crazy of a question. There's a little bit. There's quite a bit going on here. Let me give you a little hint. Try breaking up like this.
Do you divide 126 by 2?
Not by 2. What do you think? How do you think I'll do it? So you have a rectangle, guys?
Take away 9.
Take away 90, yes. So guys, you have 2 shapes. You have a triangle and a rectangle. You do not know the base of the rectangle. We know the height of the rectangle is 8. I do not know that base, which happens to be the base of the triangle as well. The base of the rectangle is also the base of the triangle. They're shared, right? Brayden, go ahead. Of course, yeah, go. No problem. And then this angle has to be 36 degrees. Why? So we're doing 126 minus 90. That's why. And of course, I need to solve for this side as well. So we have quite a bit to do. Going to work on that, and I'll walk around and help you guys out. Most going to work out too. So you have to do some trig. Big time.
Wait, what are we trying to find of the square?
So what you want to do is you want to solve for x. So what kind of trig function are you going to do to solve that? Yes, good. And then you can then use Pythagorean theorem to solve for y and get the area of the triangle. Ah, 8 meters. Hold on a sec. Okay, so our answer is going to be in square meters. We'll have to convert afterwards. Oh, yeah, that's kind of a pain in the ass. So that's all right. We'll deal with it. I'm sorry. Sorry for language.
Wait, what do you turn that into? Like 52 point or 53? What is it?
No, you can leave that. Yeah, then you want to do 81 minus that number. Just that's fine. You can make it 52.99. That's fine.
But it's an 8, so we have to round that up.
Oh, let's see.
52 point-
You can make 53. It's fine. It's fine. Yeah, this one's kind of a crazy problem. Okay. First of all, you want, hopefully you guys can get X. What do you guys get for X?
Is it this?
I'm not-
What do you guys get for X?
This. I don't.
No, that's why. Yeah, she gets 7.2 for X. Oh, and 5, oh, you're still on alcohol, sorry.
Keep getting it wrong, so I was like trying to figure out what.
I switched X's ones.
No, you're not supposed to do 9.23, so it's 9.783.
I did, 9.83.
So that's fair, so I got that also. Yeah, I got 9.9. Yeah.
Okay, this is 2-1 in the answer, so. Right, nice way to.
Oh, if I just, you probably round that a little.
Okay, but it's fine.
I got X by being signed, and then I just.
Oh, got it.
By doing yours.
Well, actually, you have your XY reverse, that's all. No, you're fine, no, you're fine, you're fine. But I just reverse my, you reverse your XY compared to mine. Okay, guys, what do you get for this length here? You got 7.28?
Well, I got 6 cans.
Was that?
I got 6 cans.
6 cans, you're right, there's 6 cans. Oh, wow, good job, you're like way ahead of us. Yes, it is, you get 850 as your area? Here?
Yeah, like 834.21.
Okay, good, okay. We still got a few more minutes left, so I don't wanna, get too ahead of ourselves, but, okay, so you guys, okay, guys, please, thank you. X, okay. So, how I guess, what do I do to solve for X? What trick function do I use here? Sine or cosine?
Cosine.
Cosine, right? Because it's adjacent. It's not opposite.
My Y thing, and then I did.
I mean, if you mix X and Y up, I don't care, but since I'm calling this X.
No, I just like, I used what I found for Y to do with
Sure,
pan.
that's fine, yeah, also, that's fine. And Y, you use sine, right? So let me show you my answer so far.
Sorry.
Here we go. Okay, so let me direct your attention to the front here. So I did sine of, actually I did cosine x, sorry, cosine 36 of x over 9, solve for x, I got that. I did Pythagorean theorem, solve for y, or use a trig function, I don't care, it's up to you. It's up to you. Now, once you have those sides, can I get the area of the rectangle? 100% you can. Once I know what x is, I just do 8 times 7.28. Once I know what x and y, I can do 1/2 times x times y and get the area of the triangle. Now I got the triangle and the rectangle. Awesome. What's that area? 77.51. But that doesn't help me because you told that each can is 450 square feet, right? So how do I convert the square feet? You're doing the conversion. You multiply that by that number to convert to square feet. Then what Kira did, so did you divide by 150?
Mhm.
Yeah, so what Kira did at the end, she took her total area, divide that by 150, and that would get me the number of cans I need. Divide that by 150. That should be 5.56 cans, but you know, you still got to buy a 6 can because after 5 cans, you're still not fully painted. So it's actually 6 cans. I add both areas up. Both. So do you get, what do you get to the area of the rectangle, Maggie? Good. How about the triangle?
9.2.
Should be 19.26. See?
Okay.
Oh, it's not 28. It's 7.28 times 5.29. 5.29 is the height of the triangle.
Oh, is it like converted into something?
No, not at all. That should be 5.29. Hold on. What do you get? Oh, you forgot square roots.
Oh.
Got square root. Guys, square root when you do Pythag. So actually I'm glad that Maggie brought this up. So Maggie solved for x correctly, it's great. She got 9, is great. She did Pythag to get y. She got y squared was 28, but y is the square root of 28. So be careful there. So yeah, you're okay after that. But see, something like that wouldn't be too punitive. I would see that. Like I'd probably take off a point on a test. This actually would be a pretty good test question too. I like this question a lot. Actually, I really love this question. So we'll talk more about that next week for sure. Okay. Just to wrap things up with the clinometer situation, let me talk about that, which I cannot find that worksheet. Hold on. Where is it? Downloads. Darn. I do not know where it is. Maybe there. Oh, good for me. I found it right away. So I'm gonna ask you guys to finish this off. So if you think about it, like for number 2, remember you're standing by the football field.
It'll probably get better. Because right now it's like everyone's
Hopefully you guys are okay with the clinometer situation. Anyway, there's another worksheet you guys are gonna work on for homework as well. It's right here. I'm gonna hand it out to you guys. And we're all done. All right. Stop recording.